This is part 2 of section 1.5, and in this section you'll see there are a lot of problems that have tables in them. And this problem says, find the pattern in the table, then find h, height, after t, time equals 6. And so you can see this table has 2 rows in it. The first one is time, and the second one is height. And then it shows that as time increases, height also changes. And so this table could be talking about a moving object. So for example, a paraglider that's falling in the sky starts at a certain height at time equals 0, and then travels through the sky and ends up at a different height at, say, time equals 4 or 6. And so the first thing you want to do to solve this problem is to find the pattern in the table. And how you find the pattern is you look at the difference in the height during the different times. So for example, between time 0 and time 1, you can see that the height decreased by 210. And then same thing for between 1 and 2, 2190 minus 1980 is 210. And then you can see the same thing happen between 2 and 3. It decreased by 210. And so you can kind of start to see a pattern. Every second, the height decreases by 210. So we found the pattern in the table. And when you see a change happen over time, that's just another way of saying rate. So we know that this is actually the rate of the change. It's actually r. And if you remember that formula we've been using, d equals rt, this is the r in that formula, it's rate. Okay, so we found the pattern in the table. Now what we have to do is find h after t equals 6. So here you have 0, 1, 2, 3, 4, 5, and they want you to find it at 6. And the best way to do that is to write a formula for the new height. So we'll call it height, h. So the new height, which you can kind of think of as the guy here at the bottom, that new height is actually the initial height, so when he's up here, plus the distance, this distance that he's traveled, that brings him to the new height. So you can kind of think of this formula verbally as the starting point, so the initial height, plus the distance that the object travels. And so to get the new height, you basically need the initial height and add the distance that the object has traveled. And you kind of know some of these already. So from the table up here, you know that the initial height right here is 2400. So you can plug that in. We know that the initial height is 2400. And now we want to add the distance that's traveled. But how do we find the distance that's traveled? Easy. We go back to this formula, d equals rt. And we don't know what d is, but we do know what r is. Remember, we found it out here, negative 210. And so we'll plug in d equals rt here. And I'll just write it as rt. And then we'll actually put in what we know. So we know that r is negative 210, and we don't know t. And so that's how you get that formula. H, the new height, is actually equal to 2400 plus the distance traveled, which is negative 210t. And for simplicity, you can actually write this again as 2400 minus 210t. And there you have it. There's your formula. But in the question, they're actually asking you, find h when t equals 6. So here you have the formula, and you can just plug in the t. And so you know that it equals 2400 minus 210 times 6, right? T equals 6. And if you solve that out, you get 2400 minus 1260. And then to finish it up, you get 1140 as the new height. And so that's the answer. At time equals 6, the new height is 1140. And again, you did that with 2 steps. First, you find the pattern in the table. So you know that's negative 210, that's the rate. Then you put it into the formula. New height equals the starting height plus the distance that it traveled. And that distance, d, is equal to rt from that formula. And then you just plug in the r you found and you solve for t and you're done.